let's see. We're at layer 5, right? I'm sorry. We're at layer 4. I'm sorry. It is 4. Trying to put this in as few words as possible, but it's not easy to do in this layer. I'm trying to use the right word here. I don't want to use the word guaranteed, though. I'm going to come back to that word. I'll stick with guaranteed. I'll stick with guaranteed now. I can work around it. So, the transport layer. So now we've got a file we're sending across. Might be that PowerPoint file, sales.ppt, right? So we got this sales.ppt. And of course, it's a PowerPoint file, and inside of Cisco, we're awful proud of using PowerPoint. Everybody wants to use PowerPoint and everything. So let's just think about this PowerPoint file. This PowerPoint file, let's see. Let's say we're having a half-hour meeting. That's, 75 slides at Cisco? So let's say that's 27 megabyte file, right? We always have these big files we're sending across the network. Networking, you don't send a big file across the network in one big chunk. It's sent in little, it's like a book. I'm going to borrow this. If I was wanting to send this as a file across the network, I can't send this entire book. It's full of pages. So what do? I have to start breaking this down into chapters and pages, something easy to send across, because let's say I can only send this much across at one time. I have to determine how many of these pages I've got. I've got to start breaking this big file down, and that's called segmenting data. So at the transport layer, when these files come down, we start segmenting these. So we've got our PC talking across a network to our server, and let's say we're pulling information across. So here's our sales.ppt file. So we have to start breaking that down. How many segments, how many chapters do we have to send? I'm going to be sending you 10 chapters. There's a 10 chapter file. 20 chapter, how many ever files? So we've set up our session. These people are talking to each other. It creates a logical tunnel of communications from one end to the other. And now the person who's requesting that using file transfer protocol, let's say it's FTP, he says the file that you're wanting to get is going to be, let's say, 75 chapters. 75 segments to move this file across there. He tells this person, hey, there's 75 segments I'm sending you for this file. He breaks it down, that file, into those. So this person's expecting 75 different segments. And we want to make sure it gets there. Depending on the application, if it's file transfer application, if you go to FTP, the definition of FTP, somewhere in it, it will say a guaranteed service to move files across the network. Provides reliability, reliable. That'd be another word we could do, reliable services across there. So if my application decided to use FTP, reliably it's going to cross it. Well, what's that mean, reliable? Well, it means that I break this down and I send segment 1 across. When this person gets segment 1, guess what? He puts it together and says, I got segment 1. He sends back a response and says, I've got segment 1, send me segment 2. He knows he got the segment. He knows he got that. Now send 2. So this person says, all right, I'll send 2. He gets that. I'll take 3 now. A lot of especially your data applications, have always been designed to use this. You guys have always heard these terms, TCP/IP. Has everybody heard that? TCP/IP? Guess what this is? Guaranteed is Transmission Control Protocol. TCP. Transmission Control Protocol says, I'm going to tell you how many segments you're going, and I'm going to send them to you, and then you're going to tell me if you got them. And if you don't get them, you tell me. So if he sends 1 across and I get it, I say send me 2. I send 2 across, he says send me 3. I send 3 across, it's going across. And then something happens in the middle of 3. You don't get the whole chapter. He waits and he waits and he's got a little watch and he's time, and that's you've heard applications time out. Guess what they're waiting of here? Where is it? I didn't get it. Send me 3 again. He says, I need to see 3. I haven't seen it. What does that give your customer? Reliability. Guarantee that that's going to go across there. It's guaranteed services. It's guaranteed. That's why your data applications always have used TCP. First of all, networks used to suck. That's a technical term. I've heard too many engineers say it. I've heard too many engineers say this sucks, and it's got to be technical. So, but this is guaranteed. So your data applications, your databases and all this, to make sure that your databases are right, this is what we use to go across the network, TCP. Now, what's the cost of this? There's nothing free in life. Nothing's free. Maybe the love of my dog, Bo. Doc and Bo. Doc's dead. Bo's my new dog. That might be the only thing that's free, because he loves me to death no matter what mood I'm in. Now my other dog, my wife's dog, Bella, she doesn't love me at all. So, but what's the cost here? Delay. I have to send something, then I have to wait for you to get it. So if it goes all the way across the world, I have to wait for you to send all the way across the world back to tell me you got it before I can send something else. So it will delay, and the cost of more network traffic. Not only am I sending the traffic across that's real, I have to wait for a response that's going to be network traffic to come back. Yeah. Absolutely. Now, we've found a way to cheat this a little bit. Actually, if all this works right and everything works as it should, the network on each device, we have this thing called a TCP sliding window. So if I send 1 across and it works, and I send 2 across and it works, and I send 3 across and it works, he gets 3 and he says send me 4, and I go back and I said all right, here's 5. After a while, both ends say this network's pretty reliable. What if I could send 6 and 7 together? What if I just say, hey, I'm going to send you 6 and 7? Would that accelerate transfer rates? Yeah. And then this person comes back and says, I got 6 and 7, send me 8. Well, if it worked for 2 segments, let's do it again. Let's send 8, 9, and 10 across. Supposed to be a line there. He gets all 3 of those, comes back and says, send me 11. I'll send 11, 12, 13, and 14. I can actually increase the number of segments I send based on the reliability of the network, which accelerates transmission rates. And then and I can go up to 15 segments. Standard TCP/IP, I can send 15 segments at one time. And so I could actually get up to where I'm sending 15 chunks at a time, which would really be good. Accelerate that. And if anybody loses something, let's say I get way down here and I'm sending 50 to, and I'm using 15 to 64. And he sends it across. And something happens in here, let's say to 63. He's going to come back and say, send me 63 again. I didn't get it. So he's going to keep up with it too. And then I won't send 15 the next time. I'll send fewer until it's proven reliable and does it again. Yeah. So I never used to talk about the AMs about that, but we have application acceleration now that we'll talk about at the end of data center that will actually come back to this. But that's TCP. Now, there's best effort. Best effort. There's another protocol out there, application layer protocol, that you could choose to move a file across a network. It's called TFTP, Trivial File Transfer Protocol. It's an application layer protocol. And if you look at its definition, it says it moves a file across a network without reliability. Without reliability. In this case, if we chose TFTP to move this file, this guy says, I've got 75 segments, here they are, 1, 2, 3, 4, just sends them out. What's the benefit of that? Huh? It's faster transmit rate, but where's the guaranteed services? So if I have a database application, I probably wouldn't choose this. This is called the protocol. This is best effort. It's called user datagram protocol. UDP. So you could have TCP/IP or UDP/IP, depending on what you're sending. Your application layer chooses it. Chooses it.
Could you give an example of this? I mean, where is this? Where was this used? Because if
all right, I'm about to do that. I'll give you an example of this. Back in 1997, a little fella, well, he's not so little, he's pretty tall actually. A guy named John Chambers. Anybody ever heard of him? Now, Johnny Chambers had been a president of Cisco for a couple of years. He was taken over and he was trying to really, it was a great time of networking and all this, and he stood up on this campus somewhere and talked about the vision and strategy of Cisco moving forward. Now you have to look, Cisco was in essence a routing and switching company. We created routers, husband and wife team, right? And up until the early 90s, in 1993, Cisco started acquiring switching companies. So we were a switching and routing company. The internet was going to be born, and we had acquired a few companies and everything, but Cisco needed to talk. They wanted to be an industry leader and talk about transformational technologies from Cisco where they wanted to drive networking. So in 1997, John Chambers stood up on this campus to a bunch of investors and said, our future is this. Long distance charges are going to become free because they're going to all be turned into packetized IP. And voice and data networks are going to converge. Cisco's collaboration architecture didn't just start last year or 2 years ago or whatever. It actually started that day. John Chambers said voice and data networks were going to converge and Cisco was going to be key in making it happen. Now, let's look back. Back then, the internet was, you were still using, at best using dial-up. Most people didn't even know how to access the internet. There wasn't a lot of information out there. Customers' networks weren't very reliable. There wasn't a data application that was nearly as important as voice back then. PBX was really important. When we were saying we're going to put that voice on a data network, people laughed. Everybody laughed at John. Everybody said, John, what's he drinking? What's he smoking? His vision didn't match what people saw as reality for today, but they weren't thinking down the road what possibilities could be. So we're going to put voice on a data network. The most important thing, now why did Cisco do that? Why did Cisco want voice on a data network? Excuse me? It could make the network more important. It would make people think about the network more than anything else. They put reliability in the network. Back then, people still had hubs in their network. We'll talk about how unintelligent a hub was. But people were still running their business applications. You have to remember, email wasn't really that important back then. So people had no data applications that they really thought were that critical. But voice was our only communications method. And if I'm going to put voice, that 5 nines of reliability and everything on a data network, what am I going to have to do? I'm going to have to buy switching. I'm going to have to put reliability in there. I have to buy more intelligent switches and routers. And who sells the most intelligent switches and routers? Us, right? So it was to drive our business, our core business. That's all it was for, to drive the ability for that. Now, if you have a choice of voice on a data network, which one of these are you going to use? Are you going to use TCP or are you going to use UDP? Why?
Because it's a kind of real-time communication. If you use TCP, the real-time communication doesn't work well.
So you're saying that the delay factor in sending something and waiting for the return is not going to work with voice. Yes, there's your application. There's your example of why voice and video, because it has to get there quickly. You have 150 milliseconds to get that voice to you and keep it going. It's streaming through your network. I can't send just a word and it get lost here, or a syllable and it get lost in the network and then retransmit it. It's not going to sound right. It's not going to sound right. It's not going to sound right. You get it? So we had to use a UDP type protocol for voice and video. So what's that mean? Your network's got to be prepared for it. It's got to be prepared for it. So you've got to engineer your networks for this. You've got to be able to start saying, that's voice, put it first. Let data get there. Somebody's downloading a file, let them slow down. They don't know if it's going to be 1 second more, but let's get that voice through there, because it'll kill a voice call. It'll kill a video call. That's why we use. This is critical. The first thing I used to, again, they hired me to sell voice and video, more voice than anything at the time, on networks, and I sold a ton of it. And I go to customers, and the customers would tell me, first off, my data network sucks, a technical term. I'll say, so do you have any data applications that's important to you? Yeah, we got data. Well, let's fix it for that with the idea of putting voice on it after we fix it, because I don't want a cap case. I don't want to have to revisit this over and over. This was a way for Cisco, understanding this is a way to talk about Cisco's availability, making networks available and intelligent enough to make this stuff work. In this era of video, this is really important. Because voice, when we talk about voice is just little bitty packets. What's video? Huge packets got to go across the network. A voice call could be 8K payload. 8 kilobytes, that's it for voice. And very small stream across the network. But for video, if you're wanting to do high definition video, it's over 2 meg. Over 2 meg of flow through a network. I mean, it's got to get there quickly, and we can't retransmit it. That's what gave you the robot dance, whatever it was. So that's the importance of this. Cisco knows how to make this work. A lot of you came from competitors, Avaya, Nortel. All of these competitors struggled with putting voice off of that PBX platform onto a network. Why? Yeah, it was Avaya. I used to sell against Avaya, and I'm telling you, Avaya had the greatest PBX that I've ever touched in the world. The Avaya G3R was the greatest PBX. In the era of PBXs, it was the pinnacle as far as I'm concerned. Loved the box. But guess what? Avaya didn't do networking. And what'd they do? For about 6 months, they told all of my customers, our IP telephony solution that's supposed to look like Cisco's runs real well on the Cisco network. Why? Because the network can give you that service. Can make sure it works. And what I do, as soon as a customer would call me and say, we need new switches and routers and everything, I slowed their deals down. I said, I can sell you the same thing in one step. And I had a competitive advantage because it was a combination of my IP telephony and my networking, and it worked together. That's the benefit of it. And we slowed down every deal and I was in big accounts, and Avaya was in every one of them. And I slowed down. I stopped every one of their deals by having these discussions with the customer. It's great that they've got a box that they're putting on the network to try to do this, but how are you going to make sure it's doing it? You've got to make sure the network knows about it.
Did it cost the customer more on services to integrate Avaya into?
Oh, absolutely. Absolutely. Because you have to understand, all these technologies, standards don't just pop out of the air. It takes 24, 36 months for standards to happen. And then everybody has to bake it into their hardware and stuff. Again, a difference in Cisco switches and routers and our competitors, a lot of our competitors, and we'll talk about this in switching a little bit more, is we design our ASICs, our chips, to be reprogrammable from our software. So a feature that you need today on a box that you bought 6 months ago, we can actually give you tomorrow's feature on yesterday's hardware by just an iOS upgrade because we design our own. Our competitors, what do they have to do? They have to wait till the chips come out with the standard, which may be 24 months from now. And you got to buy a whole new device to do it. That's the difference. That's the difference. Huh? It does cost. It does cost more. But long term for a customer, what costs more? Doing without it? Not being flexible and nimble? Or without the technology? That's the difference. And in today's world, how fast are these waves coming? Are they coming faster or slower? I'm talking 1997 for IP telephony. We really didn't start selling it until 2000, 99, 2000. But think about how fast the waves are coming now. They come faster and faster and faster and faster. So nimbleness, flexibility, the willingness of that architecture, that network to be able to change dramatically, it means more today than it did back then. Absolutely does. From a business perspective. From a business perspective. Not a technical perspective, from a business perspective. And that's what we've got to, that's why those architectures matter. People, we use that term way too loosely, the architectures. But it really does matter. Does this make sense? So whenever you think about the transport, this TCP, UDP, yeah, technically that's what it does. But what it is the ability of the network to be able to compensate and understand the requirements of the technologies running across it. Voice and video are going to use UDP, and if the net, that's where our competitors failed. Microsoft is coming out with Link and all this, and guess what? They're coming out with go with HP for your switching, go for Juniper with your routing, go with this, go with that. Is that going to give you everything you want? I don't know. Is it going to make you nimble, flexible? No, probably not. That's how we used to win our deals, is go in there and say, we have a holistic solution from the net, from source to sink, and everything in between. And customers bought in on it. Now, who was number one back in 2000 for voice? Who was number one worldwide in voice? Nortel. Nortel Networks, number one in voice. Absolutely. And they were a great company. They were a great company. I'm not going to talk, I would never talk bad about Nortel, Avaya, or their products or anything. I'm telling you, they made some bad decisions. They made their senior leadership made some bad. The guy who lives across the street from me worked for Nortel for 18 years. Great guy, great worker, smart guy. But guess what? They didn't see the need, that network need. They didn't develop the things that we did in there to make this work. And guess what? Where's Nortel today? Non-existent. Non-existent. A sad thing, right? Avaya. Avaya is a great competitor of Cisco. But Avaya is not doing as well as they'd like to. I can guarantee you that. They're not. And again, this network does matter. Why? Because we understand what the requirements are for that, for voice and being able to converge all that. We have network assessments. Our partners and everybody do network assessments. We go out and look at your network first before we just throw it out there. That's what you've got to do. You've got to make sure. You don't just go out and build a house anywhere you want and hope that, I'm going to build a 5-story house on this land. You've got to make sure your foundation is going to support it, right? You certainly want to do that. And that's what this is. That's what this is. So, what time is it? Oh, it's only 10 o'clock, so we can go on a little fast. We can go on a little bit further. Does this make sense? So, the transport layer is really important when you talk to customers about voice and video, about the need of the network to support these things. It's more important today than it's ever been because video is brutal. I'll just tell you that right now. Video is brutal. Anybody in here used to sell Tandberg? Any Tandberg? Yeah. Did Tandberg go to IT? What do you think IT would say when Tandberg knocked on a door? Yeah, Tandberg was very, very successful, but they stayed away from IT as far as they could because IT knew exactly what video would do on their network. Right? Not on my network. No way. They sold it to the business and forced it down IT's throat, in essence. Yeah, that's what they did. Why? Because business people have all the clout. Is IT a cost center or are they a revenue center? Do they get budget or create budget? They're a cost center. And they're always over budget, they're undermanned, they're all this, the networks, and it's the truth. They've disassociated themselves with the business in a lot of cases, and they don't talk about the value they do for the business so much. So they're just seen as plumbers inside their own organizations. It's not the best place to go for most of your solutions. I'm not saying get out of IT, I'm saying bring the business into IT. Bring the requirements. Yeah, it's important to sell to the business leaders. Because that's what we did here. I mean, we had to go talk to people we'd never talked to, and that's why they hired me, because I was a telecom manager, and I'd walk into a telecom manager's office and I'll say, let's just talk about the future. I'm not going to talk about specifically about Cisco's, but here's what's going to happen. How are you going to adapt to this? Your people out here on the outside are going to require this of you in a very, very short period of time. Are you going to be ready to address it and get you ready? Same with video today. We're not yet in the era of all of this. Cisco's got this term that we use, and I'm not picking on marketing. I think it's a great term. We want to make video calls as easy as phone calls, right? It's a lot easier said than that. A lot easier. And you think IT doesn't stay up at night worried about that? Daggone right. They worry big time about that. Because they're afraid to go back and say, I can't do that. Because they think they're going to get fired, and they may. They may. So, now we get down to where Cisco lives and breathes. Finally get down to the nitty-gritty here. Layer 3, the network layer. Let me put a word in there. So so the network layer. You've all heard the story about Cisco, right? What's the story of Cisco, how Cisco started? Husband and wife team at Stanford, just north of here. Back in the early 80s, they had 2 different networks. Let's draw this up. I think it was about a loaf of bread or a gallon of milk, from my experience. So let's say that the husband is working on this network. There were a lot of different types of networks. He was working on this type of network in his department. The wife was working on this type of network. She's over here. They couldn't talk. They couldn't talk. So what did they do? Well, people had came out with this new thing called a personal computer. PC was coming about. And they took one of those personal computers and they wrote some really cool software in it. They put a card that they made this side of this PC part of this network, and they made this guy part of that network, this side, and they wrote some really cool software that allowed information to flow from this side to that side. Connecting this different types of networks is what a router does. That's the birth of a router. They probably did it on campus between their 2 departments, and they went to a meeting one day and they said, hey, how's that? It's kind of cool that we can talk across this thing now. They said, yeah. Hey, could you do that for our other department? Well, let me see. Well, maybe I can. Let's see. You've got a 3rd type of network over here. I could do that. I could connect it up to a 3rd type. So on their own campus, they were innovators. This was transformational technology. It had never been done before. They wrote software to do it, and it worked. So they probably, at Stanford, they probably had a meeting with UCLA and USC and all these people, and they said, hey, did you hear what we did down there? Hey, if I send you one of those computers, can you write this and do this for me? Yeah. So they started shipping these things to all the California schools. And then people went to national sales and they said, hey, listen, I'd like to do that over here in North Carolina. And I'd like to do that in Arkansas. And I'd like to do that in Texas. And these two people said, you know what? This is some good stuff. I can make some money on this. So guess what? They said, teaching pays me this much and I see potential for this. So I think I'm going to leave my job. And so they started buying these things. They maxed out their credit cards, buying PCs and writing this software. They were, didn't have a great business model and everything. They were geeks. Get it? They were geeks. They went out and started looking for venture capital. They looked for people who would give them money. Nobody wanted to give them money. They didn't. This was really transformational technology. People didn't want to give them money. Finally, somebody back in 1985 said, you know what? I think this has got some, but the one thing I want you to do is you two geeks can't run this company. We need to get somebody who knows how to sell this stuff, a marketing or a salesperson, and that's John Morgridge. And that was the requirement for them to get their big chunk of venture capital, is to get the geeks out of in charge and let the marketing and salesperson take over. And when they did that, they got a big chunk. They could actually start rolling these things off the assembly line, becoming a bigger company, formulate their business plan. The rest is history. That's what a router does. Its basic functionality is to connect different networks. Today we use that in the voice world as a voice gateway to connect us up to the PSTN. So we can call home and say, honey, what do you need for me to bring home? Again, I think that's what started this. I think he was at work and she was at home and she needed a gallon of milk. She called one of her friends here because she couldn't get a hold of him, and he was behind a locked door and they couldn't communicate. And he came home and got in trouble, and he says, I'm going to create something so I don't have that issue again.
That first box they created, is the museum piece somewhere? Do we know what happened?
I have no idea. I'm sure it's not in the museum. I don't think it's in a museum. I mean, we've got some older boxes in there. And it wasn't even called a router. It was called a gateway, by the way. And they weren't the only company who came up with this eventually. IBM sold gateways.
They actually, those two, they actually started building their own circuit boards to get that connectivity working from the physical side.
Yep.
And then write the software that then sat
Right,
on chip.
right. And what we've done is we've taken out the fat that we didn't need, wrote our own code to get the maximum out of the box. That's what that did. Because the box operating system was doing all kinds of other things that they would never want to do with this specialized box. So what they did is they said it was taking processing power. And you have to remember, processing power was at a premium back then. I mean, you've got more processing power in your watches today than this box ever had, right? So just a little bit of savings there would get, and it slowed down the networks between here and here. It slowed them down, absolutely, because it did everything in software. But it was called a gateway. It wasn't even called a router. It wasn't until probably the late 80s, early 90s that we really called these routers, specialized boxes that did this, a router. But it connects to similar networks. That's what it does. And again, we had, IBM had their own, the interface back into the mainframes. Novell had theirs. Everybody had their own software gateway that did this up through there. But today, our routers connect to similar networks all the time. They provide many more services than most people ever imagine. We'll do a whole thing tomorrow on routers, and you'll see what they do. IP, your IP addresses. Back then we had all kinds of different protocols that we used, and everybody came up with their version of this. We were using different protocols. Today, IP is the way to go. IP is the way to go. The Internet Protocol. And the Internet itself drove everybody to that. When you want to connect to the Internet, you have to use that. That killed token ring. It killed all the everything else. It killed everything else because IP. Routers. How do you get your IP addresses? How do you get your IP addresses? If I, and I'm going to kind of recreate this in newer terms. If I come in and I have a switch here and I connect a PC up to it, or if I have an access point and I connect up through wireless my PC, how do I get my IP address? Yeah, it's actually this. your devices actually are configured. They're told that there's a service out here, some kind of box or something out there that will give you an IP address. Instead of me configuring an IP address on your PC, whatever it is, on your PC, which may work in this network, but if you want to take that PC to the hotel or someplace else, it might not work. We actually dynamically assign IP addresses. And we can thank Microsoft for this, probably more than anybody, with dynamic host configuration protocol. DHCP. In your PCs, if you look in your PCs, there's a checkbox. It says, what's your IP address? It says, get one from the network. So when you connect up to any network, the first thing your PC just says, it yells out, hey, I need an IP address. And it goes through the network and goes to this, and he's got a list of IP addresses that are assigned for that specific network, and he'll lease you one, and you keep that for a certain period of time. Now that IP address at your home, I'll use the ones that you might see at your home. 192.168.0.4. That might be something you see at home. When you buy your little box at your home, how many people here have wireless at their house? Wireless routers and all that. Kind of cool, so you don't have to sit in front of, you can sit in front of the TV or any place you want to do to have all these devices. Well, guess what? That might be your IP address. When you buy that box, the big instruction sheet that they sent you said, okay, you've got a cable modem or DSL modem coming into your house, and you hook that box up here, and it's got wireless in it. And it says, on the back, it'll have a port, and you connect your PC to it for the first time. And then you go to an IP address, 192.168.0.1, which is the IP address of this router that you've got. And then you configure that. You configure your wireless, and then you don't have to be tethered by a piece of copper. And you set it up. It's got your DHCP server in it. It's set up for that. And an IP address has got at least 3 parts, at least 3. It's got the IP address. It'll have something, so let me do this, 192.168.0.4, let's say. It's going to have something called a subnet mask. It's going to look like this, 250, if I could write it, 255, 255, 255, 0, and then it's going to have your default gateway, which might look like 192.168.0.1. That's the 3 parts you have to have. Now, it might give you some other things that we'll have in there. But this is the thing you have to have. And it's going to dole that out. So when you yell, hey, I need an IP address, it's going to at least give you these 3 things. At least these 3 things. And that's what it's going to say is, here is your unique address, logical. It's in software in your PC. It's in software in your PC. And it's going to, and this is the decoder ring. Because this actually has 2 different parts of information. It's got your street number and your house number. And it's all determined by this. In this case, I live on 192.168.0 Street, and I'm house number 4. There can only be about 250 houses on my street. That's all I can have. Probably don't need that many more than those devices in your house. I have 46 IP devices in my network, potentially, if they're turned on. I'm a geek. I'm a geek. And I don't use this, by the way. I use this IP address scheme. But this, if I wanted less streets, more houses, I could do this. I could put a 0 there. Now I move this over to here. I can have several thousand houses, but fewer streets. Fewer streets, depending on how I dole that out, those IP addresses. And you lease them by default for 7 days. And halfway through, you go back out there. But this is how you get your IP addresses. Now, why is that important to today? Why is it important? This is the first part of mobility, folks. This is first part of mobility. How many of you like mobile? How many? Yeah, everybody likes mobile. Everybody wants to be able to do this. This is basic networking on how it works. When you This device here, again, it's really nice to have 3G, 4G and everything, but you know what? I like Cisco's network too. It's faster, especially seeing this is a 3G device. So guess what? I hook up in a wireless LAN here. What's it do? Goes out and gets an IP address. I've got a PC. PC's got wired or wireless, so I'll have multiple NIC cards inside of my devices. All this networking, it looks like magic. And we want customers to think it's magic. We want to be so transparent to them. But it's complicated in the back end. This is complicated. And we have to have customers understand that we've made this look easy, and we're adding more things to it. What if I want to now drive this device to where I'm on a video network? I use an iPad and I want to drive video to it. I want to have a separate network for that. I might want to identify what that device is. Mobility has taken a whole new different form. Other than now I don't have to have a wire connected to me, to now, what if I have, how many people here bring multiple devices in their network with them? Yeah, you have your phone, your iPad, and your PC, depending on what you want to use, what you want to do. Yeah, a lot of different things. So you might be using 3 IP addresses, 3 different ones on your devices. So the network's got to be smart enough to identify what that device is, should I let you on the network, and what kind of applications should go to that device. I probably don't want to stream 1080p to this. It's probably not efficient, right? Don't want to do that. If I have an iPad, that's a good place to do it. So I want to be able to do that. So we've got to add a layer of intelligence now to decide that, and decide if this device is even worthy of getting on my network. Is it a security risk? Those are the things that we have to do when people get on networks today with this mobility strategy. This BYOD is real, right? Yeah. How many of your customers are talking about BYOD? How many of you? Yeah. Everybody's talking about it. Why? Yeah, exactly. Exactly. Might be based on time, might be based on device, might be based on application, might be based on a lot of different things. Yeah. What else? What's another reason BYOD? Exactly. I read a really interesting report. It was actually written by one of our larger partners about that, about getting Emily. I'll go back to Emily. To call, you know, this is called an iPhone, right? You guys know that. This is the most misnamed device in the world. Oh, yeah. The most misnamed device in the world. Now, I'm going to tell you a little story about Emily, and then we'll take a break. Emily, of my 2 daughters, Emily's the oldest. And Emily's not been so concerned about grades her entire life. Emily's probably the most well-rounded kid. Socially, she can fit in anywhere. She could sit in here with you folks and get along with you. And she can work with teenagers and all that. She's really just amazing. But she's never really thought a lot about grades. So she goes to 6th grade, from elementary school to middle school. And I had a HTC EVO. That's the phone I had. She said she wanted one of those phones. Well, she didn't have a phone, so I went and bought her a track phone, just a pay-per-minute, ugly phone, the ugliest one I could find. And I gave it to her, and I said, for emergencies, this is what you do. I gave her 800 minutes of talk time, so she can call me from anywhere. She can do anything she wants, but it wasn't cool. And she says, I want your phone, Dad. I want the phone like you've got. I said, Emily, you make all A's in the 6th grade. I'll buy you whatever phone you want. We'll go to the Sprint store. I use Sprint. We'll go there, and that day, as soon as you graduate 6th grade with all A's, I'll get you whatever phone you want. Oh. Not thinking she'd do it. She goes through the entire school year and makes all A's. Every grading period she's coming back. She used to never show me a report card, but when she had all A's, it's, look what I got. Right? All the way through. Her last grading period, she pulled a B. B in math. So, well, exactly. So my wife looks at me and says, Eddie, you're going to be the biggest, yeah, the north end of a southbound mule that you've ever been when you tell her she can't have that. And I was in a it was a tough decision, but I was going to stick by my guns. So we go to her graduation, 6th grade graduation. We're in year-round schools and everything. So there's 127 students in her group of, there's 4 tracks. But she's competing with 120, or attending school with 127 students in her track. So they give out all the awards, the perfect attendance awards, which I never understood when I went to school. Why do you want to go to school every day? Take a sick day here and there. All these people who got all these awards and everything. And then they came up with the last student of the year. Now it's not based just on grades, but it's based on your, all the different characteristics. And she won the award. So Emily Martin walks across the stage as student of the year. My wife looks at me and said, "That's the easiest out you'll ever get in your life with her." So she comes off there, and I say, "Let's go." I said, "I know you made a B, but that student of the year, it shows me you're doing." So we go to the Sprint store. She gets her HTC EVO. Now Emily gets that HTC EVO. Second month after she's had it, I look at my Sprint bill. 2 numbers jump out at me. $5,279 and $29. What do you think she was using that device for? Yeah. The texts are $5,279 and only 29 minutes of talk. She had 3 days left in the month. Thank God I had an unlimited texting plan, first of all. And 25 of those 29 minutes were to me, because she texts me and I text back 2 words. Call me. Call me. Because I don't, eventually people's thumbs are going to fall off these kids. But back to your point, do you think you're going to be able to force Emily to take whatever you give her? Back when I started, I was happy to get a desktop. I was happy to get a 3270 terminal emulator and a phone, and that was my workspace. And I went to work every day, and I was happy because they were paying me. Do you think that's going to work with Emily? No, it's not. BYOD is all about this next generation. This next generation. They don't care. It's not fair. I want to be able to bring that. And guess what? Companies are now saying, guess what? We'll supply you with this type of PC, or you can bring your own. And I don't even pay for it. That's the wave. That's why BYOD is important. And mobility is a key part of that, because Emily's not going to sit at a desk. When I went to Blue Cross and Blue Shield, I was a manager of voice and data operations. When I first walked in there in 1995, they rang a bell at 9 o'clock and at 5 o'clock. You know what that was for? It's like school. At 9 o'clock, you're supposed to be sitting down, and at 5 o'clock, you can leave. Could you do that today? How are you going to get an employee? Who cares about that? Do you think IT cares about that? Do you think IT revolutionized this and said, do you think the IT person stood up inside of a business leaders meeting and say, "You're in sales, you're not going to be able to get the best new salespeople because you're not giving them the right devices. We're going to open up the network to everybody to come in here"? Do you think IT did that? They fought it tooth and nail. But you can't stop it. Consumerization of all this. It started with wireless LAN. The first technology that I ever saw drive IT nuts was wireless LAN. It had been around for years. Once it started getting into my house with these little wireless things here, I started saying, why can't I have that at work? That's when people started making it part of the business process. And it's never stopped, and it won't stop ever.
Well, we have a strategy, even, not to take up too
No, go.
We would actually go to the largest CEOs and give them as a gift an iPad.
Oh, absolutely.
Which drove it straight from the top down to IT.
Yeah.
Right? So because the first thing he'd do is have the iPad and say, "Why isn't my Exchange working on it?"
Yeah, exactly.
And so it had to open it up.
Yeah.
And so that once that dam broke, then
It's over with.
Yeah.
It's over with. And it's all about, flexibility in the workforce, flexibility of, it's not work hours, it's not work days, it's work minutes. It's work minutes from everywhere. How many, you guys know as well as I do, I've taken conference calls on soccer fields. That's work. I have to do that. Hey, I'm sorry, honey, I know you're playing soccer. Let me go over here in the corner. I'll be talking business and everything, and I'll come back. What did I miss? Kind of thing. That's the way work is today. And it's not just that way for us at Cisco. Yeah, we're on the leading edge of that always. But they have to do that. at-home workers, the mobility. Again, the first time the iPad came out and somebody gave it to a senior vice president or somebody, and they brought it into work, that's when the gates were unlocked. Because nobody's going to say no to them in IT. They can't. They cannot do that. Not and keep their job. So we're going to continue on with the OSI model. We're almost through. There are only 7 layers. We're down to layer 2. We've talked about packets. So whenever you hear the term packet, you're going to think of layer 3. And again, earlier on we talked about taking data and breaking it down into segments at layer 4. Then we take that individual segment and we're going to break that down into smaller usable chunks, and we're going to put that into a packet. Now a packet is actually like an envelope. An envelope. Now when you send a letter in the mail, what do you put on your envelope? The addresses of where you want it to go. Well, we do it here. Now this is a logical address. Again, this is assigned in software, so it happens in your operating system. So no matter if you're using Windows or if you're using Apple or using Linux or whatever, it's in the software of how they get their IP address to connect on a network. And we take this data, we break this segment down into multiple smaller chunks because a packet can only carry so much data. So we take that chapter that we have, the book is the file that we're sending or the information we're sending. We take that and we break it down into chapters, which we call segments. And now we're taking those individual chapter pages and we're going to send those a page at a time. So chapter 10, page 2, chapter 10, page 3, so to speak. And we'll put those inside of a packet, and our IP addresses inside of that packet are going to be what we call source destination. So if I'm looking with a network analyzer, watching packets go across a network, I can actually see the packet, the data inside the packet, but I can also see who it's from and who it's to, just like a letter when you're sending that in the mail. Now, that is at layer 3. In order to get that on a physical cable, we have to have something that takes the logical world into the physical world. Into the physical world in some way, shape, or form. And that's what we do at the data link layer. At the data link layer, we have that packet that comes down that's got the IP address, source destination address. And now we're actually going to start making it go out some kind of interface, some kind of physical connection. It may be wireless, right? Maybe a wireless, we might use radio waves. But this is where we have to adjust it. And it's going from device to the device. Networking is actually looking for network to network. This is actually looking from device to device. How do I get it there? How do I get it there? So I have to have a different envelope. The envelope is actually called a frame. A frame. So we actually take one envelope and put it inside of another envelope. And it's going to have a source destination as well. We have to put that. And it's going to be based on MAC addresses. The MAC addresses. The MAC addresses are the burnt-in addresses inside of your PC. In theory, you can't change it. We know we can change, do a lot of things. But in essence, it's the burnt-in address that identifies your PC. Now I'm going to lift this up, but I won't turn it around and do all that crazy things to make your hard drive go crazy. This PC has an IP address in it. It's got network interface cards. It's got a network interface card where I can hook a copper cable into it. That's one MAC address. And it has a wireless MAC address for the wireless interface card. It probably has a Bluetooth MAC address because Bluetooth is another type of network we have. So it'll have multiple MAC addresses in there. Now, if my IP address changes, does my MAC address change? No, it doesn't. You carry this with you whenever. So if you take this here and connect into Cisco and get a Cisco logical IP address, your MAC address is still your MAC address. You close it down, you go to the hotel tonight, and of course your boss is going to want you to do some work. you have to connect up on their wireless network. Your logical IP address will change, but your MAC address will still be the same. You carry that MAC address with you everywhere you go. Source destination, again, we take the packet and put it inside the frame. So the packet is inside of here, it's what we carry. Moves data from one device to the other. This is where a switch comes in. And we'll talk about switching in the next segment. Let me do the fundamentals of switching. 2 segments from now. But that's what a switch operates on. Switches live at layer 2, traditionally. They live at layer 2. They look at MAC addresses. They're smart. Switches are the first place where we actually put network intelligence out there. The first place where we can actually start manipulating and looking at things. So the smarter a switch is, the more intelligent your network can be from end to end. Cisco sells a lot of switching. And again, Cisco didn't invent switching, but boy, they acquired a heck of a lot of it. And they've done more for switching than any company has. And it's certainly, we've benefited the most. Over 35% of our revenue is based on switching products. It's one of our big core products and everything. And Cisco's dominated the switching market for many, many years. This is also the only place in the OSI model where we actually do error detection. Let me show you. So if I have a PC and it's connected up to a switch port, and I'm sending to another PC on the same network, I'm sending it, I'll send this information out. When I send it out, the switches are, the data link layer is the gateway from logical to physical. Just think about that. It comes in, this is a physical address now, and I'm going to send this out in ones and zeros across some kind of cable or some kind of wireless network. That's what I'm going to do. He knows the integrity of the data, what he's sending, and we want to make sure that the other end gets it the same way. And this is the best place to be able to do reliability, to do that. So what he does is at the end of every frame, we have a FCS, a frame check sequence. Some people call it a CRC, cyclic redundancy check. And all it is a formula. When he's getting ready to send these out in ones and zeros, he's the only place that knows where it's at. He puts these ones and zeros through a formula. How many ones in certain places and how many zeros in certain places, and runs it through a formula and comes up with a number. And that number is put in the end of the frame. And then it's sent out across the network, and any device that gets it, that has the intelligence, will rebuild ones and zeros into the frame. And if they want to see if it came across well, they just check that number and run it through the same formula. So it's kind of like saying, I'm sending this frame across the network, and when I do my calculations, I know that the number at the end of this is going to be 316. I run it through a formula, 316. I convert it to ones and zeros, I put it on a copper cable, Cat5 cable. It runs across, goes through the next device. The next device is a switch. It operates at layer 2. When it comes into that switch, it rebuilds those ones and zeros into the same frame so he knows where to send it, so he can get the addresses. And then before he does that, he says, okay, ones and zeros for this. If I run it through that formula, I should see 316 at the end of it. Bang! It's good. I'll use it. What if he comes up with 326? Yeah, it's incorrect. Something happened between when you sent it on that copper cable and when I received it. Most of the errors that used to happen on networks all happened at the physical layer because we had all these poor pieces of cable and poor installations and this, that, and the other. It's called a framing error. And that switch, because he looks at this and says, well, the integrity of the data is not right. This is not true data. This is rumor. This is not good. So he throws it away. He throws it away. He doesn't tell anybody either. He puts a little counter out there and says, I threw one frame away because of an error. Now what does this do with your data? What about the application layer? What is the application? Remember when we talked way back to just a couple hours ago, when we talked about that transport layer, right? If I'm using a TCP application, what happens? The other end doesn't get all the segments, the chapters. So what's he do? He says you have to retransmit. But if you're using UDP, it just keeps on going. It just keeps on going. Yeah. This is the only place where we actually do error detection inside the OSI model at layer 2. The only place. And switches do it all the time. And again, most of your errors are a bad cable or this, that, and the other. That's where most of your problems are at. Right? Somebody's, I can remember early on when we used to do different types of Ethernet networking. I was at this one office and a lady she got a speeding ticket. She was not happy and she came in and threw her purse underneath her desk and knocked the wire loose. All of a sudden she's complaining the network's slow, network's slow, network's slow. Everybody's complaining the network's slow. So I had to go in there and what did I find? I found a cable that had been knocked loose. We were getting framing errors. There were framing errors out there. I had to go troubleshoot that. Well, today's world, with wireless, we still have framing errors. They still check that stuff. But it's not nearly as often as it used to be. But this is the only place in the OSI model where we actually do error detection. The only place. And this switch, although it will count that, he doesn't go back to this PC and say, I threw something away. He doesn't care. It's at the higher level, with the application level that uses either TCP or UDP that determines if I'm going to retransmit or not. So if it's an IP phone running this, it's not going to resend that word. It's too late. If it's a video device, they ain't going to resend it. But if it's a database application, then it will certainly resend it because we certainly want that decimal place in the right place if it's my paycheck. Because I need all the money I can get. Like I said, wife, $2. All right? Does that make sense? Does that make sense? This is the only place, and we'll revisit this when we go into fundamentals of switching and run frames and all this through there this afternoon. You'll see how this switching, again, that's a really important part of Cisco's portfolio, and where Cisco has stressed the intelligence of this, and we'll talk more about that as well. And going back to layer 1, that's just the physical layer. And that's, if I could spell radio. I guess it's etc. Physical layer is just a copper, right? The fiber optics, the radio waves. When we talk about wireless LAN is a combination of layer 2 and layer 1. It really is. It uses radio waves to connect you up to the access points. But guess what? You have MAC addresses in your NIC cards. Absolutely. And you associate on that via your MAC address. That access point will own your MAC address. Absolutely. So copper was generally what we always used, copper cabling. But then we started using fiber optics. Why did we start using fiber optics? What's the benefit of fiber optics over copper? Distance, right? Speed. Now, not saying that gigabit Ethernet is faster on fiber than it is copper. It's not. It's just the amount of speed we can get in fiber. We've yet to find the end of what we can put through fiber optics as far as bandwidth. Fiber optics is really just, in essence, a glass tube that we convert ones and zeros to light waves. And we run that through there. So I could actually have 10 gigabit Ethernet running through this one fiber strand using one light wave, one color, and at the same time, I could have another color going in at the same time, and they won't interfere with each other. So we've yet to find how much at the end of fiber optics it is. So we can keep adding more and more and more capabilities inside of fiber. Distances are certainly important. Cisco supports 60 kilometers or 100 kilometers, 60 miles of connection between our switches with certain optic cabling. So you can run these things a long way. Yeah. And we'll talk about how it's deployed inside of a network, how it traditionally does when we talk about LAN switching and stuff, how it might look inside of a network, because there's going to be a combination of those. And of course, when we talk about radio waves and wireless, that certainly drives us to BYOD and all this mobility strategy that we have for our customers. Nobody wants to be connected. How many people have iPads in here? How many people use iPads? Where do you hook those things into your Ethernet switch? You don't, do you? Yeah, you don't. So you think wireless is going to be more and more important to your customer? Absolutely. What are we doing? We're trying to put more on it, more devices. That's why there's some great changes coming in wireless in a not so distant future about the capabilities of wireless and what we have to do. It's certainly a discussion point for your customer that leads to all types of business models and business drivers that you can have a conversation around. Mobility. So it drives you to security, drives you to intelligence in the network, drives you to video, drives you everywhere. So it's a great, and everybody's using it. So they're very familiar with it. It's a great conversation piece to start out with. And you can take your customer anywhere you want them to go. But that's the OSI model. Now, somebody was talking about any books or reference material that you might want to look at. And I don't get paid any of this. I know the guy who wrote this. I've actually met him. But this is a really good book. Cisco Networking Simplified. If you want to, it's like me. Believe me, if we started lining this place up with the smartest people, I'd go to the back of the line automatically. That's where I start. Because I know I'm not that smart. But this is really a simplistic way. It uses a lot of some of the common things that we've done. Now, the guy who wrote this, I've been doing this longer than he wrote this, but he did a really good job of explaining how networks work. It's great reference material for you to see. It takes you in some places I don't go and vice versa. But it's a really good book to just start out with. And again, I don't get paid one thing for it, but I think it's a really good reference book to start out with this. This class itself is probably good month 1 through 6 and really good after you've been here a while because you get distracted, you forget about it. And for anybody who's done any kind of instructional design, you know that you're probably going to retain maybe 30% at best of what we talk about during this 3-day class. But after a while, you'll probably be a little more important to you after you struggle with some of the stuff that you may have forgotten. But I'm just saying that's a great reference material. In that book, it talks about the acronyms to remember the OSI model. Let's see, we have all people seem to need data processing. Please do not throw sausage pizza away. Please do not tell salespeople anything. That's the SE version. Yeah. So you can have all that. So, Excuse me?
Please do not take salesperson's advice.
Yeah, that's another one. Yeah. Please do not take salespeople's advice. Yeah. Well, I'll tell you, there was a couple of salespeople I'd love to continue to work with for years and years and years. They were good. And there were some that, absolutely. So that's the OSI model. It's the framework that we'll go across with all this, right? All this.